Hello friends, so today in this video we're gonna discuss the latest Atcoder zone energy programming contest. So we're gonna discuss the first three problems. The third problem is actually asked to me to solve. That's why I'm making a video on this problem also. So let's stay tuned in this problem. The first problem is very easy. It states that you are given a string of length s of length 12 and you have to find out how many occurrence of zone are there. So you can just iterate over the string and find out how many zone are there. As you can see, it is 1 here and 3 here and so on. So you can just match out whether zone is present and how many times this zone is present, capital Z, O, N and small e. Okay, so the second problem is so to understand this problem, actually you have to draw it out to even make it more clear. I'll tell you with the example only. It states that there is a tower of height 1000, you can assume that 1000 meters, and then what you can see in this problem is there are different UFOs. Okay, the UFO is at a distance d and height h. So as you can see, there are different UFOs. So as you can see that this is one UFO, which is this is a tower, okay, and this UFO is at a height 10. Okay, so let's see. Okay, at a distance whose height tower is d and height h. So as you can see, this is at a distance of height this and tower this. So it means that it is a height and distance of 10. So the distance between the tower tip and the distance like this horizontal vertical is actually from the tip of the tower is 10. So that's the distance. Now what it actually states that there are n obstacles between the tower and the UFO. Okay, there are n obstacles, and what you can see in this problem is the ith obstacle is at a distance of di and hi. Okay, so there are different obstacles. As you can assume that this is some type of wall. Okay, there are different walls. So the wall also has a distance from the tower tip and a height. So you are given like these heights. Actually these heights are actually given. So the distance between the tower tip, this is given, and actually the distance and the height is given. So now what the problem is actually asking you is find out the minimum height you need to climb. Okay, so we assume that you want to climb up the tower so that no obstacle crosses the line between you and the UFO. So you have to somehow climb up the tower so that there is no obstacle between you and the UFO. So as you can see that if you climb up up till this height, then because there is straight line after this height, there is no obstacle between you and the tower. Okay, I hope you get the point, because there is a straight line joining this. So if there are multiple lines, so let's assume that this is the tower. The tower is very large, but the UFOs, let's assume here, and one height is there. So if you just draw a straight line joining this, it's not a straight line, but let's assume that I draw it out. Sorry, just drawing out with the mouse. So let's assume that this is the UFO. Okay, this is a straight line. So now if you climb up till this point or more than this point, then you can clearly watch the the UFO, because below this you cannot watch, because the UFO is fixed and the straight line joining is this only. So if you are below this point, you cannot watch the UFO because it is blocked by this wall. But if there is another wall like this, so then you have to again draw out another straight line, and then you have to climb a height of at least this, then only you can watch the UFO. So you have to find out that what is the minimum height you have to climb up the tower so that you can watch the UFO without any obstacle. So you just have to find out this, actually the distance this point, and you have to maximize this over all the positions, whatever wall is given for all the walls. So if there are n walls, for all the walls, if there are some n walls, 100 walls, so for any walls you have to just find out this distance, and you have to maximize this till what point you can climb to watch the UFO. Now if you just draw out a simple geometry, then it is actually a simple geometry case. So I'll find out for any random height. So let's say that this is the random height, this is the height of the UFO, and these are the different heights. You want to actually find out this. So let's say that this is x. Okay, this height is given to you. This is capital D, which is the UFO height, and this is capital H, which is the UFO distance. Okay, you are also given small d, which is this height. This height is actually the height of the tower, or the obstacle, and this is the small height, the small distance. Sorry, I actually write the opposite of it. This is actually height, this is actually distance, and this is small h, and this is small d. Okay, then you actually want to find out this. So what you can simply see in this is just draw a line like this and draw a line like this. Now what you can see here is the angle, like as you can, if you know that this is a straight line, then if you draw any line like parallel to the x-axis, then these angles are always same because the line is same. Okay, so if this angle is same and this angle is also same, so if you know this height, like you know this level, okay, and you know this height, so this is actually capital H, this is small h. So this height is actually, as you can see, small capital H minus small h, and this distance is actually what you can see, capital D minus small d. Okay, this is actually, so tan theta is actually the height upon perpendicular upon base. So this is the tan theta, and if you do the tan theta of this triangle, so this triangle tan theta we have done, and this triangle tan theta, if you want to do this distance, you know, which is d. Okay, so this distance is actually d. So what you can see here is key, if you want to take the height, which is capital H, like small h, and this if you want to find out, oh sorry, this is the distance small d, and this is, let's assume, y, which is this height. This is y. Okay, this is capital H, this height, which is the height of the obstacle. This is small h, and this is y, which is this height. You just use this formula such that capital H minus small h divided by capital D minus small d into d, or small d. This will give you y, this height. If you subtract y from capital H, this is capital H, this is y, so you will get this height, which is x. And you want to just maximize this over all the walls, and that's the problem. Okay, so I can show you the result, my submissions. So okay, yeah, so that's what I've done. Just use double, so capital H minus small h, capital D minus small d into d. Okay, this is the A1 height, and just subtract it from small h, which I've told you, which will give you this x, and then you have to like maximize it over all the values, and that's the answer. Okay. The last problem, actually the third problem, it actually states that, I'll tell you in simple terms, it states that there are n candidates in the team. So there are n candidates in the team, and each candidate has 5 properties: power, speed, technique, knowledge, and inventiveness. So these are defined by these variables, and then you actually want to form a team of 3 persons. From these n persons, you have to form a team of 3 persons, such that, let us define your team power as the maximum of members power. So I'll tell you with example only. So let's assume that these are the members. Okay, there are n members. Let's assume, just take out there are 3 members in this only, so we have to take all the 3 members. But let's see that if you take out any 3 members from the n persons, let's assume that if you take out these 3 members, then this is the speed for everyone, like this is the speed for every participant. This is the other power, the speed, and the second was power, and so on. So this is the power for every candidate, speed for every candidate. So you want to find out the maximum of them. Okay, if you choose out these 3 candidates, then the maximum of each thing, power maximum is 8, the speed maximum is this, and everything you have just find out. And then you want to find out the minimum of them. So as you see that, finding out all of them with finding out the maximum of all of these powers, and then finding out the minimum of them, which is 4. So you want to actually, in the end, what you can see here is, this is the most important line, you have to maximize the possible value of your team total strength. So as you can see, the team total strength is the minimum of all of these values. Actually you're finding out the minimum value, and you want to maximize this. So I have actually told you in my binary search playlist, if you find out this, some like this term, you have to maximize the minimum value. Then it is actually a clear-cut indication that it might be solved, not 100%, but it might be solved using binary search. Okay, so you can think in that direction also, but just take a hint from that. You can think in that direction. Maybe it can be solved, maybe it cannot be solved, but you can get some clear direction also. So what you can think in this problem is, it is also asking like that, yet you have to maximize the minimum value, because in the end you are actually minimizing the strength, like you're taking out all the different categories, and what you're doing, you want to find out the minimum value among all the categories, and you want to maximize the minimum value because you want the power to be maximum, but you are in the end finding out the power using the minimum values. So what you can easily do here is, you cannot take out every possible triplet, because as you can see n is up to 3000, so it will go up like above 10 to the power 9 operations, and you cannot do this. So what you can observe in this problem is, I'll tell you in simple terms. So okay, if we just think over the binary search intuition only, then what you can think in terms of binary search is that these are different categories. Okay, so if you want to binary search it, over which thing you can binary search? You can binary search over the solution. Okay, it's always beneficial to do binary search over the solution. What is the solution? The solution is this value. Okay, so you can binary search over this value. You can just ask different questions in binary search. You actually ask questions. So you ask question that whether there is some possible triplet which will give me a value more than 4. Okay, so as you can always observe that let's assume that these are the 3 triplets which are chosen. Okay, this is the minimum value among all the possible values. Okay, so this is the minimum value, which is fine, but this value is actually greater than 1 2 3 4, like 1 2 3, like this value is greater than 1 2 3. So if I have taken in mind that, okay, can I find out a triplet such that its value should be greater than equal to 4? Can I find out? That's my question. I want to answer that question. Can I find out a value which has a power in the end, the total team power, more than 4? Can I find out that thing? Now how can I find out that thing? Let's assume that if I take out all the categories and just 1 2 3 4 5. Okay, if I take out all the categories and I want that my total, okay, so I want that my total strength should be greater than equal to 4. So what I will actually do here is, I will iterate over each person's category and check that whether it is greater than or equal to 4. If it is greater than equal to 4, I am actually forming a bit mask for every person. Why this will actually helpful, I will tell you in the end, then you will understand. But let's assume that I iterate over this person, and just copy this out so that it will become more clear, and I will just write down easily. Okay, yeah. So let's assume that I want to make them greater than equal to, or let's assume that this is equal to 6. Okay, I want to just check for 6. Okay, just iterate over all the possible things and just this is for every person. Okay, so is greater than equal to 6? No. Yes, no, and yes. So this is actually a bit mask of 5 size, in which every bit is actually denoting us that whether that particular category is greater than equal to 6 or not. Okay, then I will go to the next thing. Then as you can see, greater than equal to 6, yes, no, and that's for the last thing, yes, no, yes. Now what you can see that if my total category, this is my total thing. Okay, now let's assume that if in the end I want to find out the minimum of them. What is actually finding out the minimum? It is actually the minimum value is actually telling us that everything should be greater than or equal to that value. There is nothing smaller than 4. I hope you get the point. The minimum is actually telling me that among all the values I have, among all the category value I have, like 8 9 9, nothing is smaller than 4. The smallest is 4. So if my question is denoting that the smallest is 6, nothing is smaller than 6, because that's my power. So every category should be greater than equal to 6. If every category is greater than equal to 6, then what it means that every number, if I choose out a triplet, every triplet or every category should have more than 6. Every category should have at least a number greater than 6. So if I'm checking with 6 only, then what I can observe here is everything is greater than 6, then everything should fill out. If I do an OR of all of these numbers, this actually tell me that, okay, if I choose out this triplet, if I choose out these 3 numbers, then for the first number it is greater than 6, second number is greater than 6, If I choose out these numbers, then obviously, because as you can see, if these numbers are chosen and I want to maximize this, so for every category I will maximize this, and if I choose a maximum number, they are already 6, so like the number will be already more than 6, because these are the maximum number. Okay, so that will obviously be taken. So if that will be taken, the number which will come in the end, that will be obviously greater than 6, and if it is greater than 6, this will turn out to be 1. Okay, so if I do an OR of all of these values, it turn out to be 1. If I do a OR of this, it will turn out to be 0. This is 1, 1, 1. So as you can observe in this problem is, there is 1, 0, everything is 1, but this is 1, 0, which is actually telling me that, like, if I take out this triplet, this will actually not form the answer, because like there is 1, 0, and this 0 is actually telling me that among all of this category, there is no number which is greater than 6. So if I take out this category, and if I do the maximum value among all of this category, so what I'm actually doing, I'm taking out every category, finding out its maximum value, and as you can see, the maximum value of all of them is actually smaller than 6. That's why it is giving me 0, because I am actually searching for a category which is more than 6. There is no category which is more than 6 in this, like no number. So this will actually give me 0, and if this will give me 0, then this is not possible. So it means that if this, like all the numbers, if I choose 6 as the answer, this is not possible. So I have to take a number which is smaller than 6, and then check the thing again. I want to make let's assume that next number is 4, then I will again make a table and check that whether all the numbers are greater than 4. Okay, so I'll do the same thing. If you just do the thing again for 4, this will actually turn out to be 1. This is 0 and this is 0, but now if I do an OR, this will actually also become 1. I hope you get the point. So it will become 1, and now this number is actually complete, like every bit is set. So if every bit is set, now that, like, this is a possible answer, and this is the possible answer, then like I have found out a triplet. And that's what we're going to do in this problem also. So we will actually do a binary search over the values, okay, and then we just check that whether for this value we can find out a possible answer. Okay, so I have told you how to do the bit masking. So what we'll do for bit masking, actually for every number, for every candidate, we will form this bit mask. It is actually 0, 1, 1, 1, 1. This is actually a bit mask. So instead of writing this down into 0, 1, 1, we can write this down into number format only. Number format means that write it down into like what will actually this convert to in number. So this is actually 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Just add them out. That is actually the number which will be stored here. Okay, and that number will be actually stored here instead of this number. So as you can see, now you can also tell that, okay, I understand for 3 cases, like for the long cases, how you can check that. The simple thing can be, because the bit, like the maximum number in this can be, because there are 5 bits, so 2 to the power 5, which is like 32. So the numbers can be in the range from 0 till 31. So what you can do here is, you can make a frequency map of 31 positions. 0, 1, 2, 3, 4, 5, and for all the n numbers, let's assume that for the first number it turns out to be some like 16. Let's assume the second number it turned out to be 15, third number it turned out to be 3, then it turns out to be 4, then it turns out to be 10. So just mark it on the frequency table, and because the value will be always between 0 and 32, and now for among all of these values, you just have to find out a triplet, such that just take out 3 numbers, because you can do an O of n cube solution for 32 value, because this is very small. You can do this in O of n cube, but you cannot do O of n cube for this whole n numbers, but you can do this in O of like n cube. It's like 32 to the power of 3. You can easily do this. So for every possible answer, you just have to form this grid, or it's not actually grid, you just iterate over every possible number and find out its mask. Mask is actually telling that whether that number is greater than 0 or not, and just forming this number, convert it into integer, and store that integer into a frequency map. And now for this frequency map, just find out that whether there is a triplet existing, so that for that triplet, if you do an OR of that triplet, then it turns out to be all bit set. All bit set means that this is equal to 31, as you can see. So if we choose out any 3 numbers which are actually present in this, so if we have frequency map, if we choose out any 3 numbers from this frequency map, such that all of those numbers, if it turn out to be 31, then that's the possible answer. I hope you understand it. It is a little bit confusing, but I hope you get the intuition how to solve this problem out. I can show you the code part now. So as you can see in this problem, first we have making, like I have take the input of all the numbers, make them, like make this map global, store out all the categories, okay. And then what I've actually done here is, this is actually the binary search thing, okay. Check that whether the middle value is correct or not. If it is correct, make your left go to middle +1, else right equal to middle, and just print out this number. And then what you can see in this example is how this OK function is working. We have make a vector for actually frequency vector for storing out the numbers from 0 to 32, because that's the possible answer. Then iterate over every possible person 0 till n, make their mask. So like num is 0, iterate over all the possible categories. If the ith category is greater than mid, then add that number, the particular bit, in the num. Okay, this will actually make the mask for that particular person, and then add that mask into frequency map, this, okay. Then will it make a triple for loop, like as you can see, 1 for loop, 3 triple for loop. For the first for loop, so what we'll do, so this is the frequency map which actually tell me that how many numbers of each type. So if there's a mask for 2 type, mask for 5 type, how many times this number is present. So we'll do a 3 triple for loop. We'll just iterate over the first for loop. If the particular I is present, if it is not present, we just continue on, because that frequency is not present. If it is present, we'll subtract I from it, then go to the second for loop, we'll do the same thing. If it is present, then go to the third for loop. If it is present, then find out its OR. If it is equal to 31, then we just return out true, because we don't have to find out anything. But because we are doing subtraction, which means that I have taken that number and then we are going to the next step. But because now I have to revert back, I will just add that number again, and then again for the ith number. So it's like, because we do not double count any number, we do not take it out again. So it means that if the 32 number is taken, we do not, or 15 number is taken, 15 mask is taken, we do not take it again. So how we'll do thing, for the ith loop, if I take out 15, we just subtract it out and do the following for loops, and then after we have completed for the 15, I will again put that back, so that in the next for loop maybe some another number wanted, so they can also use it. I hope you understand the logic and the code part. The code will be in the description, so you can check those code out. Ask the next one. Till then, keep coding and bye.